Did you know Neanderthals are the reason we can get addicted to drugs? That's not even remotely true, but it does make a good hook for this video. You might be wondering, how does human evolution tie into addiction? Those seem like two separate things.
Dopamine.
Dopamine is what ties evolution to addiction. So, what exactly is dopamine? Well, the brain is a highly complex connection of neurons. Each of these neurons send electronic signals from one another in order to communicate ideas. So anything that you see, feel, think, all of that is just a string of neurons in the brain. The electric signals these neurons send follow the path of least resistance, aka they go where it's easy to go. Dopamine is a chemical in the brain that's most known for its very potent feel-good effect. Dopamine encourages neural pathways it's associated with, making it easier for electric signals to move through that pathway. So when later electronic signals get sent near that area, they're more likely to follow that action or idea associated with dopamine. This is a very big simplification of neuroscience, but all you need to know is that dopamine encourages you to repeat actions. In humans and a lot of other animals, dopamine is used to reward behaviors that help our survival, especially reproduction, eating, and drinking. But why are these things so important?
Reproduction.
All living things need to reproduce in order to keep living as a species. If a species or organism doesn't reproduce, then its genes are lost and won't be passed down to future generations.
Eating.
Living things also need energy to survive. Everything from thinking to moving to sleeping requires energy. If humans didn't eat, there would be no way for us to get enough energy to survive.
Water.
Water is considered necessary for all life ever, especially humans. We use water to regulate our temperature, dissolve minerals and nutrients, and remove waste products from our bodies. Because all three of these things, reproduction, eating, and drinking water, are important for our survival, the animals that neurologically rewarded this behavior were more likely to survive. So these animals who associated these behaviors with dopamine passed this connection down. This is why reproduction, eating, and drinking release dopamine in modern-day human brains and in many other living creatures. Now that we understand that, let's focus on human evolution. Many people think that humans evolved from monkeys, but that's not quite true. Both modern humans and modern monkeys evolved from a common ancestor known as Sahelanthropus tachadinus? Basically, a few million years ago, humans and monkeys were the same animal, but then we became two distinct species, which slowly evolved into modern humans and modern monkeys. We refer to these early humans as hominids, which are categorized into different species of human. But the reason our species diverged is because, unlike monkeys, humans developed
Bipedalism.
and also other reasons, but mostly
Bipedalism.
Bipedalism is the act of walking on only two legs to move. Ancient monkey human was a four-leg walker, and from as early as 7 million years ago, humans developed bipedalism. There are many benefits to bipedalism. With early humans, it helped us travel across different terrains, adapt to changing climates, have a free set of hands at all times, and it caused our brains to change and restructure itself, leading to our cognitive development as a society. You should note that early hominids didn't just start walking out of nowhere. It's likely that they knew about walking, and as time went on, they started utilizing it more and more. But how does bipedalism relate to dopamine? In a study that measured how dopamine affected movement in people with Parkinson's, it was found that dopamine could motivate them enough to move in ways they found difficult. If we apply this to early hominids, then if ancient humans associated bipedalism with dopamine, they would be able to consistently walk on 2 feet, even if it was challenging. As ancient humans started walking on 2 legs, they started to think, and think about thinking, and think about thinking about life, the universe, and everything. Curiosity is a very, very important human trait. Basically, every part of modern human life was created because humans had curiosity. The dopamine activity in the brain greatly increases when we're curious, whether it's by solving a difficult problem or inventing something new. We inherited this connection from early hominids, who utilized their curiosity to invent tools and discover fire. By inventing, they were able to increase their survival via killing more effectively, creating artificial light, and creating heat. Fire also helped create a social environment in which ancient humans could communicate and bond with each other. This helped the development of
language.
Most animals communicate, but humans are the only species that have language. Why is that? Well, during social interactions, the human brain releases dopamine and oxytocin. Oxytocin is a neurotransmitter that's related to social behavior. Similarly to dopamine, it encourages neural pathways it's associated with. The reason why humans are incentivized to be in a community is because it benefits our survival. By working together, humans can get food and other resources easier and cover each other's weaknesses. As our brains complexified, so did our abilities to socialize, specifically communication. The creation and standardization of language allowed people to communicate more clearly, making sharing complex ideas easier. So, overall, dopamine played a major role in human survival and evolution. But how does that tie into addiction? Addiction works by hijacking the brain's reward system and causing large amounts of dopamine to be released. This causes your brain to want to continuously repeat that action over and over again, creating the addiction. Let's go over how exactly nicotine and alcohol hijack your brain.
Loud noise.
Nicotine binds directly to nicotinic acetylcholine receptors and uses them to release dopamine in the brain. These receptors use acetylcholine to control fast signals throughout the nervous system, such as muscle movements and sensory information. But nicotine's chemical compound mimics acetylcholine's chemical compound, allowing it to take advantage of these receptors' natural function. Because nicotine takes advantage of the nervous system, dopamine gets released in the brain in under 10 seconds.
Alcohol.
Alcohol works very differently. Instead of stimulating the nervous system to release dopamine, alcohol shuts down part of the brain. Specifically, it turns off potassium channel subfamily K member 13, also known as KCNK13. I'm just going to call him Joe, because why not? Joe dampens dopamine-releasing neurons, so by shutting Joe off, dopamine neurons fire more. This causes much more dopamine to be released while under the influence of alcohol. Because alcohol has to travel from the digestive system to the bloodstream, then to the brain, it takes about 5 minutes for alcohol to affect dopamine levels. So overall, the systems that kept us alive and kept us evolving are the same systems that get us addicted. And that's how... Dude, that's not grammatically...
Shut up, it's the end of the video.